Let a the square y dx squared plus b dy dx plus cy equals to f of x be a second order differential equation. Second order because the highest derivative here is 2. The general solution of this differential equation is given in the form y equals to yc plus yp. Yc here is called the complementary function or the complementary integral. Yp here is called the particular function or the particular integral. Yc is obtained from the homogeneous part of this differential equation. A the square y dx squared plus b dy dx plus cy equals to 0 is the homogeneous equation of this differential equation and is obtained by setting f of x equals to 0. Now, to get the complementary function from this homogeneous equation, we need to look for the auxiliary equation. To get the auxiliary equation, we need to set a variable, say m equals to dy dx and the y equals to 1. So if we do that, this homogeneous differential equation will now be am squared plus bm plus c equals to 0. The general solution of this homogeneous equation, which is the complementary function yc, depends on the roots of this auxiliary equation. Now, if the roots of this auxiliary equation are real and distinct, real and distinct means that the discriminant, which is b squared minus 4ac, is greater than 0. Now, if the discriminant of this quadratic equation is greater than 0, it means the general solution of this homogeneous equation is obtained from the formula yc, which is equals to a e to the alpha x plus b e to the beta x. M is equals to alpha, m is equals to beta are the solutions of this quadratic equation. A and b here are any real constants. Let's say the roots are real and equal, that is the discriminant, which is b squared minus 4ac, is equals to 0. Then the general solution of this homogeneous equation is obtained from the formula yc is equals to a plus bx times e to the alpha x. M is equals to alpha is the solution of this quadratic equation. A and b here are any real constants. Let's say the roots are complex conjugate, that is the discriminant b squared minus 4ac is less than 0. The general solution of this homogeneous equation will be in the form yc is equals to e to the alpha x into a cos beta x plus b sine beta x, or yc is equals to a e to the alpha x cos beta x plus epsilon. M is equals to alpha plus beta I, or m is equals to alpha minus beta I are the complex solutions of this auxiliary equation. Alpha is the real part and I here indicate the complex part. You see, in the first m, the real part and the complex part are separated by a positive sign, and then in the second case, the real part and the complex part are separated by a negative sign. That means here the sign have changed from positive to negative. When this happens, we say that this other part is the conjugate of this other one. So that's what they mean complex conjugate root. So the roots need to be a conjugate of each other before this formula can work. Now let's look at how the particular integral of the differential equation can be calculated. The particular integral depends on the nature of this function f of x. That means if f of x is a constant, the particular integral will be of the form y equals to lambda. Now, if f of x is a linear expression, the particular integral will be of the form y equals to lambda x plus another constant mu. Linear expression means f of x is in this form, ax plus b. If f of x is an exponential function, that is a function of this form, e to the alpha x, the particular integral will be of the form y equals to lambda e to the alpha x. Now, if f of x is of the form a cos bx, the particular integral will be obtained by the formula y equals to lambda cos bx plus mu sin bx. If f of x is of the form a sin bx, then the particular integral will be of the form y equals to lambda cos bx plus mu sin bx. If f of x is a polynomial expression, let's say of degree n, then the trial solution will be y equals to lambda 0 plus lambda 1x plus lambda 2x squared plus up to lambda n xn. You have to take note that if the complementary function already contains a term in the trial solution, we will need to multiply the trial solution by x. So it is preferable that we find the complementary function first before we suggest a trial solution or a particular integral. Now let's do some examples to see how this concept can be applied. Find the general solution of b squared y dx squared plus 16y equals to 34x plus 13 into e to the negative x. You know, the general solution of a second order differential equation is always in the form y equals to yp plus yc. Yp is the particular integral, yc is the complementary function. We always look for the complementary function first before the particular integral. The complementary function is obtained from the homogeneous equation of this second order differential equation, and the homogeneous equation is the square y dx squared plus 16y is equals to 0. So the homogeneous equation is always the left hand side of this equation, or the side of the equation where they are derivatives equated to 0. To obtain the auxiliary equation, I need to set y equals to 1 and then dy dx equals to, let's say, a variable m. Substitute the value of m and the value of 1 in this equation. This equation now will become m squared plus 16 equals to 0. This equation m squared plus 16 equals to 0 is called the auxiliary equation, and the solution of this homogeneous equation depends on the nature of roots of the auxiliary equation. From here we see that m squared is equals to negative 16. That is m squared plus 16 minus 16 is equals to 0 minus 16. That's subtracting 16 from both sides of the equation. I'll have m squared plus 0 is equals to 0 minus 16, which is negative 16. M squared plus 0 is m squared, which is equals to minus 16. So that is how I arrived here. That means from here m will be equals to the square root of minus 16. You know, from indices, if a squared is equals to n, to make a the subject of formula I take the square root of both sides, which is like raising to the power half, and when I raise this left hand side to the power half, I also need to raise this one to the power half. I also know that from indices, a to the power nm is equals to a to the power n times m. So it means that from here 2 times half is the same like 2 here 1, 2 here 1. So I'll be left with a to the power 1, which is equals to n to the power half, and then a is equals to n to the power half, which means also that square root of n. So applying it here, m will be equals to square root of 16. This also means that m is equals to square root of negative 1 times 16, which also means m is equals to square root of minus 1 times square root of 16. You know, square root of 16 is equals to plus or negative 4. Square root of minus 1 from complex number is I, so m is equals to plus or minus 4i. That means also m is equals to 0 plus minus 4i. Now the roots of this auxiliary equation are complex conjugate. When the roots of the auxiliary equation are complex conjugate, that is, let's say m is equals to alpha plus minus beta I, then the complementary function yc is given by the formula e to the alpha x into a cos beta x plus b sine beta x. Looking at this form, our alpha here is 0 and the beta is 4. So it means the complementary function here yc is equals to e to the 0 times x into a cos beta, which is 4 times x, plus b sine beta x, which is 4. Simplifying this, yc will be equals to a cos 4x plus b sine 4x. You know, e to the 0x is the same like e to the 0, which is equals to 1. So 1 times all this will give this. So the next thing here is to look for the particular integral yp. You know, the particular integral depends on this non-homogeneous function on the right hand side of the equation, or the side of the equation where there are no derivatives. We said before that if f of x is in the form ax plus b, the particular integral will be in the form lambda x plus mu. F of x is in the form e to the alpha x, then the particular integral will be in the form p e to the alpha x, where lambda, mu, p are all constants. You also know that if f of x is equals to a product of these forms, that is ax plus b times e to the alpha x, then yp will be the product of these two forms, that is lambda x plus mu times p e to the alpha x. You see, from the equation, f of x is a product of these two forms. This means yp will be equals to the product of these two forms. But you know, e to the alpha x in this product is e to the minus x, that is alpha is minus 1. So yp will be lambda x plus mu times p e to the negative x. You have to take note here that writing out this form in yp, we don't copy the coefficient of x here, which is 34. We don't copy this constant, which is 13 here. So we just write the form. But writing out this form here, we need to copy this, mining about the coefficient of x in this form, which is minus 1. Now, to get the complete particular integral, we need to look for the values of the constant lambda, mu, and then p. To look for these values, I need to set yp to be equals to y. That is, y is equals to lambda x plus mu times p e to the minus x. Now I need to differentiate y twice. I substitute in the place of this derivative, and then I substitute y in the place of y here. Then I expand and compare coefficients to obtain the values of lambda, mu, and p. That means dy dx from here is lambda p e to the minus x minus p into lambda x plus mu times e to the minus x. You know, from the product rule of differentiation, if y equals to uv, then dy dx will be equals to v du dx plus u dv dx. From this equation, if we take u to be this, lambda x plus mu, and v to be p e to the minus x, then dy dx will be equals to v, which is p e to the negative x, times the differentiation of lambda x plus mu, which is lambda. You know, to differentiate lambda x plus mu, I have to differentiate term by term. And when I differentiate mu, which is a constant, I have 0. When I differentiate lambda x, I'll have lambda. And then lambda plus 0 is the same like lambda. So that is why this lambda is here. So the next is to take u dv dx. That's lambda x plus mu. You know, the differentiation of p e to the minus x is the same like minus p e to the minus x. That's p is a constant. I differentiate only e to the minus x. And the differentiation of e to the minus x is the same like minus e to the minus x. So minus e to the minus x times p will give minus p e to the minus x. Now minus p e to the minus x times lambda x plus mu mu will be minus p in bracket e to the minus x. And you see, that is how I arrive here. Now this can still be simplified. That is the same like factorize out e to the minus x. I'll have lambda p minus p into lambda x plus mu all into e to the minus x. And you see this is the same like lambda p minus p lambda x minus p mu. That's I multiply the bracket by minus p times e to the x. So this means dy dx can be simplified to lambda p minus p lambda x minus p mu times e to the minus x. Now I need to differentiate this one more time again. That is the square y, the x squared will be the same like the differential of this with respect to x times e to the minus x. To differentiate this, I need to differentiate term by term. I know when I differentiate lambda p, I'll have 0 since it's a constant. I differentiate p lambda x, I'll have p lambda. And when I differentiate minus p mu, I'll have 0. So 0 minus p lambda minus 0 is negative p lambda times e to the minus x. Now plus the differential of this times this. The differential of e to the minus x with respect to x is the same like negative e to the minus x. That's I differentiate the exponent times the function e to the minus x. That means here I'll have minus lambda p minus p lambda x minus p mu times e to the minus x. So I've carried the differentiation of this using the product rule. So let me recopy the yc that we obtained earlier on here as a cos 4x plus b sine 4x. So you see that this part here can still be simplified. E to the minus x is common to all the two terms, so I can factorize e to the minus x out. And if I do that, I'll have negative p lambda minus lambda p minus p lambda x minus p times mu, all this into e to the minus x. This one can still be expanded as negative p lambda minus lambda p minus which is plus p lambda x plus p mu all into e to the minus x. P lambda is the same like lambda p, so minus p lambda minus lambda p is the same like minus 2 lambda p plus p lambda x plus p mu all into e to the minus x. So it means the square y, the x squared, can still be simplified to this, that is minus 2 lambda p plus p lambda x plus p times mu into e to the minus x. Now I need to substitute y and then the square y, the x squared, in the differential equation. That is minus 2 lambda p plus p lambda x plus p mu times e to the minus x plus 16 into y, which is lambda x plus mu times p e to the minus x is equals to 34x plus 13 times e to the negative x. You see here p is common in all the terms, so I can factorize p outside. So this part of the equation becomes minus 2 lambda plus lambda x plus mu into p e to the negative x. If you look at this and this, you will see p times e to the minus x is common in the two, so I can factorize it out. So that means this equation can be rearranged as minus 2 lambda plus lambda x plus mu plus 16 into lambda x plus mu all into p to the e negative x, which is equals to 34x plus 13 times e to the minus x. You see, I can still expand this and simplify. So if I expand this, I'll have 16 lambda x plus 16 mu. Now if I bring this one down, I have 2 lambda plus lambda x plus mu plus this. If I arrange this, I'll have lambda x plus 16 lambda x is 17 lambda x. You see, equally mu plus 16 mu is 17 mu, and then minus 2 lambda. So that means all this can be simplified to 17 lambda x plus 17 mu minus 2 lambda into p e to the negative x is equals to 34x plus 13 into e to the negative x. Now I need to compare the coefficient of the two sides of the equation. You see that p times e to the x is the same like e to the minus x. Pe to the minus x is equals to e to the minus x. It means p is equals to 1. That's if I divide both sides by e to the minus x, e to the minus x here will be 1, here will be 1, here will cancel, will be left with p equals to 1. That is p equals to 1. Now if I compare this part and this one, you will see that 17 lambda x will be equals to 34x. That means 17 lambda is equals to 34. Now if I divide both sides by 17, 17 here 1, 17 here 2, 17 cancel here. That means lambda is equals to 2. That's lambda is 2. 17 mu minus 2 lambda is equals to 13. That is 17 mu minus 2 lambda equals to 13. Means that 17 mu minus 2 into 2, since lambda is equals to 2 is equals to 13. That means 17 mu minus 4 is equals to 13. You see, if I add 4 to both sides of this equation, this one will turn to 0. That means 17 mu will be equals to 17. That's 13 plus 4 is 17. Now this means mu is equals to 1. That's if I divide by 17, divide this by 17, 17 here will cancel, I'll have 1. It means here mu is equals to 1. Substituting these constants in this equation, it means yp will be equals to 2x plus 1 times 1 times e to the negative x, which is the particular integral of this differential equation. Now it means the general equation of the differential equation in this form will be y equals to yp plus yc. That is 2x plus 1 times e to the negative x plus yc that we obtained before. That is a cos 4x plus b sine 4x. So this is the general solution of this differential equation with real constants a and b. To be able to continue seeing your videos, you need to subscribe to the channel and like any video that you see. Subscription is free. To subscribe, you come down to this subscribe icon and you click. When you see subscribe, it means you have already subscribed. And then to like, you come to this thumb icon, you click. Sometimes you may want to subscribe, they ask you to log in. Yes, you need to log in to YouTube using your Gmail. To log in is free and to create a Gmail is free.